All right, so we starting. We want to go with some topics to revisit, stuff that you guys asked for. You all asked me to talk about ASCII. You all asked me to talk about programming paradigms, and you all want me to take a look at structs, right? So if we started with ASCII, I don't want yellow ink. All right. That stands for American Standard Code for Information Interchange. ASCII is just a little. ASCII is just it's a simple enough concept where each character like capital A is assigned a numerical value, right? Which actually could be represented by a binary value as well, right? So if this is 128, 64, 32, 16, 8, 4, 2, 0, right? So if it is that we have the character A, in terms of understanding that computer systems communicate using binary number systems, computer systems communicate using binary number systems, we have a numerical representation for each character. And of course, the important characters are A, this is 0, right, which is 48. And then we have 48 or 45, boy. Let me just confirm that it's 45, right? No, it's 48, right? Because 49 is 1, okay? So 0 is 48, and if I have 48 being represented in binary, right? My number is 0, 0, 1, 1, 0, 0, 0, 0. And you all would notice that I always write any binary number smaller than 255 using 8 bits. Okay, once we are dealing with binary, you typically the standard is to represent the values as 8 bits. So we have A, we have 0, and we have common A, which is going to be a 97. Okay, so if we have 97 as binary, here we have 0, 1, 1, 0, 0, 0, 0, 1. And these, every value, every number, sorry, every character has a different value associated with it. And there was a program that I gave in one of the assignments that had asked you all to manipulate binary in some manner, right? Sorry, to manipulate the characters in some manner. And I saw that in your attempts with it, some of you went, if the character that you're currently at is A, or if the character is B, or if the character is C, and you all did that for the whole capital letter set and the whole common letter set. And yes, that could work, but that's not really effective programming, because we know that if I ask you to enter a sentence and you have to say how many capital letters in the sentence and how many common letters in the sentence, the better thing to do would have been to use the ASCII representation, right? The better thing to do would have been to use the ASCII representation to be able to figure out, well, how many letters are inside here? How many numbers are inside here? How many symbols are inside here, right? Or you could have used these symbols otherwise. And so what I'm going to do is I'm going to write a quick little ASCII program, something that I'm going to do two things. I'm going to print out all the ASCII values and the numbers associated with them, and then I'm going to allow us to write a sentence and then say how many capitals and how many commas in the sentence. And we would get that using the ASCII values. So right, so this is VK class _1.c. All right. So what is our goal here? Our goal, and this is a refresher because we've done this before. We've done this before. We said we want to write a program that allows us to print out every character and its ASCII associated value. Okay? And for us to do that, we know that we can go from 0 to 255. So we can have an integer saying int n, and you could use a for loop. You can say for n is equal to 0, semicolon, n is less than n is equal to 0, n is less than 256, semicolon, n plus plus. Okay? And what do we want to do? We want to print out whatever ASCII value is associated with n. How do we do that? We know that we can typecast, so we can say printf %c, because it's a character we want to print out to be visual, \n, and put that %c in single quotes so that I will see what character is actually in between those single quotes. All right? And I'm going to print out the character representation of n. So I will typecast n, the value, to a character, and what it will say is whatever value that character is associated with, it will show the ASCII that this number is associated with, it will show the character representation of it. So I have my number from 0 to 256, and I will see what that number would represent if I'm using ASCII. Right? I could put a getcha here. And if I run it, I have a whole bunch of characters coming out. Right? Now if I put the let's say a dash here and says ASCII number %d, I could put back n here, and now I would see up to 255, right? So ASCII number 0 is nothing, right? ASCII number 9 is, I guess, a tab space, right? If I go in here and I say Alt 9, hold on a second, please. Yeah. Right. Well, I get some weird circle coming out. Right. And sometimes you'll get it different from the you see how you have like these little smiley faces and stuff there for the different ASCII numbers. When you put it in a notepad, it might represent differently. Let me see one. Okay. Now I got my smiley face 2. All right, I got a darker smiley face 3. And how am I getting it in Notepad? If I press the Alt key on my keyboard, all right, I wonder if I can use an on-screen keyboard for this one. All right. If I press the Alt key on my keyboard, and then I press the number, ooh, I don't have a number pad. All right, yeah. If I press the Alt key on my keyboard, and if I have like a number pad here, why does the on-screen keyboard not have a number pad? All right, options, let's see. Turn on numeric keypad. All right, so let's see if it'll work here, right? If I press Alt, I have Alt held down. Oops. Alt and 9. And you see, my character comes up. So you can do that on the actual physical keypad, right? You type Alt and 65, right? Alt 65. All right, well, I'm getting in trouble with it here. But whatever, this is just to visualize, right? That what I'm actually doing on my keypad at home here. Once I hold down the Alt key and I press a particular number, so if I press Alt and 23, I get that character that we have here for 23. This kind of little weird symbol with a down up arrow with a line underneath it. Okay? And so you have to remember that, like, if you think about it, backspace is a character, carriage return is a character. So like the enter key is a character, as in \n, tab is a character. So as you go through, you're seeing all the different characters that exist here. So we're seeing all the different, you're seeing things to make borders, etc. So if you have enough time, and if you think it through, you can actually draw a border on your screen. Okay? In C programming. Right? Look, you have pi here. So 227 is the pi symbol. Okay? You have an omega symbol there, greater than, less than symbols, equality symbols for maths. So there are a whole bunch of different characters, but the ones that we're mostly concerned with go from character 65, which is A here, up to 90, which is Z. We're concerned with the characters 1 to character 9, which is 48 to 57. And then we're concerned about 97 to 100 and 122, right, which is Z. And we could use this now, knowing that we can use this now, knowing that we can manipulate or text data coming in, so that I don't have to say if a particular character is A or B or C or D or E or F and write out that long list, because I could represent it numerically. Understand what I'm saying? Are you guys with me? Somebody talk now. I want to know if I fall back asleep or something. So
That's it. I understand.
you all understand. You're all with me, right? So now if I write a program, so I'm just gonna copy this, and I'm going to write a program, right? Just lazy naming these things, VK class 2, right? Let's see. And so I'm going to write a program that allows us to enter a string of text and states the following. How many capital letters are in the text and how many common letters are in the text. And then when we do this, you would see how actually simple the programming question in assignment, in coursework assignment 2 was, right? Because we could start off the program by saying, please enter a sentence, okay? And if you could do it for one sentence, you could do it for a whole paragraph. I'm not lying to you. It's very simple because all now you have to do is things repeated. So if it is that we have sentence, right? And sentence, let's say, could hold up to 100 characters. Please enter a sentence. We will get a sentence. And after we get the sentence, we want to now take a look at that sentence or that string of text, whatever was entered, and we want to count the amount of capital and common letters inside of that text. How are we going to do this? We just learned about ASCII. Our capital letters go from what? Right? Our capital letters go from, so if we have capital, we know that the capital letters go from ASCII value 65 to 90. The common ones go from 97 to 122. So if we have a sentence, right? Hello, Valdez. What I am doing in my sentence is that I'm going to say, okay, for the length of this sentence, I want to take every character and see whether it breaks down to 65 to 90, right? So let me see if my old program is still up, right? We know that capital H is what? H is 72. We know that capital V is what? V is 86, right? And those are my capitals. My capitals fall within the range of 65 to 90, not so? Yeah? So when I'm going through, I'm going to be able to count capital H and capital V because these values fall within that range. All right, my E is going to be what? My common E will be 101. So E is 101, 101, right? L is 108. So I have 108 by 2, 108, and then I have 108 here for this L, right? So these 108s are for the L's. This 101 is for the E, right? We have 100 for the D. A is 97. Z is 122. And O is 111. Now, all we're doing really is looking at the numbers. You all with me on this? You all with me on this? Give me a little half sleepy grunt or something. All right? Somebody besides Ezekiel.
Yes, sir.
All right. Thank you, Jaden. Anybody else want to show me that they're living? No? All right. Okay.
Yes, sir.
All right, good. All right. So we know now that we have all of these values within range and you know, we essentially just count in. So it's just to write the code that will do that. I could include string.h. And I could now see, right? I could say, I could put an int here, int n, and I could say for what? For n is equal to 0, so start at the beginning of the string. N is less than strlen for cent, right? Count for how much ever characters in the string, and n plus plus. So I could say that this is for each character in the string. What do I want to do? I want to check the ASCII value of the character in that string. Now, we saw previously that if I have a character B, right, if this is the character, right, if I say char x, x is B, if I go int as a typecast for x, what will be returned here will be the integer value associated with the character that is stored for x. So I'm going to get 98 for int x, right? What I'm getting here is the ASCII value. Make sense? So what I'm going to do is that I'm going to say for every character in the string, I would say if the ASCII value of that character int for ascent at position n is greater than or equal to 65, and int at for cent, sorry, at position n is less than or equal to 90. What am I saying here? I'm saying for each character in string, if it falls between, or let me say, if the ASCII value character, if the ASCII value for that character falls between 65, which is the ASCII for A, and 90, which is the ASCII for Z, then what do we want to do? Then what do we want to do? Then we want to increase something that we call like the capital count, right? And then we could have like a common count. Which makes sense. So we say capital count carried up by 1. Carry the capital count up by 1. Okay? And we could do the same thing for the common. All right? And I'm not going to type it out because I'm not a psychopath. I'll just copy the code and change this to 97. And I'll change this to 122. And I'll say, okay, if it's for between 97, which is common A, and 122, which is common Z, then carry the com count up by 1, right? So we want to carry the common count up by 1. And so at the end of this for loop, all you have to do is print out, printf, the sentence contains percent sign D, capitals. And you print out CapCut. Sorry. Right? And you do the same for commas. Right? And you do that for commas. So look at how much shorter this code was than having to type out if sent at position N is equal to A, if sent at position N is equal to B, if sent is at position N is equal to C, if sent, right? And I'm asking, and this is a question to you guys. Did it in your mind when you were writing out that long piece of code, did you think to yourself there must be some easier way to do this? Anybody who wrote that long piece of code? So the rain in Spain. The sentence contains 5 capitals. The sentence contains 9 commas. Right? Is that correct? 1, 2, 3, 4, 5 capitals. 1, 2, 3, 4, 5, 6, 7, 8, 9 commas. Did that thought pass through your head that maybe this is not the most efficient way to have done the question? Anybody who did the question or who thought about it? Right. You guys fell asleep on me? Hello? Anybody? Right. I'm pulling up the questionnaire to see if I am off the mark as well. Do you all believe my home internet is not back as yet? Then the question is giving trouble to come up. Right. So I mean the total amount of capital and common letters found in the text, right? And we could have actually even gone further and say, well, how much of each capital and common letter, which was the last thing to do. So if I wanted to provide a count of all the capitals and commons, then that now is an array that I have to use. Okay? Let me see. All right. So does this shed any light on how to do it? What to do? Let's do the part that says how much of each character. Okay, let's do the part that says how much of each character. Okay? So let's think about it like this. If we know now that we got the count of how much capitals and how much commons. But let's say this sentence. It contains 1 capital and 11 commons. But then the question asked us to say how much of each capital and how much of each common. Could anybody tell me or explain to me what might have been your approach towards doing this? Anybody? Don't be afraid to talk. You could be wrong. It'll be fine. Somebody give me a suggestion now. You all
So,
hearing me? Yes? I have no wondering if my internet not working. So if
and
I'm not... Mhm.
I was going to say, like, when you give us the time to, like, to find, like, kind of like a frequency in an array, so you could just check and see, like, if the position, like, have two for loops and check and see if the, what you call this thing, if the character occurring twice and, like, add a count to a character and print out the count and print out the character and the count of in the array.
Right. Okay. So good. So yes, you tell me something that makes sense here. Right. Let me see what David is saying. Oh, David just saying his Wi-Fi lagging. Right. That could be a mix of your side and my side. Okay. All right. All right. So let's go with what Joshua was saying. I could create an array of size 26 because I know that it has 26 letters, and set all values in this array of size 26 to 0. Okay, so 0, 1, 2, 3, 4, 5. Right, 25, 24, 23. Right, so I could name this comma array. And this means that the first position is supposed to represent the amount of A's, the second position is supposed to represent the amount of B's, etc. Yes? Yes or no? Yes or no? Yeah? All right. You guys even more silent than during the term, boy. All right. Okay. So this is supposed to represent A. This is B, this is C, this is D, this is E, this is F, this is X, this is Y, this is Z. Okay? And how am I going to now get the count for each letter? When I, at this point, say, okay, if int at position sent n, when I figure out if the value is capital or common, what I could do is I int at position sent n, sorry, int at sent for position n, sorry, I was saying it incorrectly. Let's say, for instance, that our word sent contains the value hello. So if n is here, that means that int at position sent n is currently a capital H. Yes? What I am doing at this point is that I know I could figure out what value int at position sent n is for capital H, right? And I'm just going back to my previous program so that I could get the value for H. Right. So if my value is capital H, then it is 72. Okay? So H is 72. Now, how can I get H to be represented inside of here? Right? So if I have a capital array, A, B, C, D, E, F, G, H. And all of these values inside here, 0, 0, 0, 0, 0, 0, 0, 0, dot, 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 Y, Z. All right, 0, 0. This is position 24. This is position 25. 0, 1, 2, 3, 4, 5, 6, 7. Where should H go if I have a capital H here and H is 72, right? How can I get the value at position 7 to increment? Anybody could tell me that? So that I could keep a track of my values, the different letters, the specific letters. Can I say raise your hand if you know what we're doing? And see if anybody raise your hand in the class? Because I feel as though I'm not getting any feedback.
So I came in a little late, but I'm kind of confused as to what's going on.
All right. What we are doing, we are doing part of the coursework 2 assignment, which is we were looking at explaining the concept of how we can use ASCII values to get information on text. So what I am saying is that the objective here is to allow the person to enter a string of text, and we did that already, right? Allow them to enter a sentence, and it will print out how many capitals and commas in the sentence, right? So I could say only Chelsea spoke up. And it says that my sentence contains 1 capital and 17 commas. But now I want to take this a step further and say how much of each capitals were counted and how much of each common letter was counted. And what was explained, I think, by Joshua, I think it was Joshua who explained it, is that we can use an array to store 26 values, and as we find that character, we increment the value associated with that character. And that array has to be subscripted from 0 to 25, which will give us 26 positions. So what I am saying now is that, say for instance, the value that was entered, the word that was entered was hello, the first character that we look at is going to be H. How are we going to get the array position for H to increment? We saw that H, the value associated, the actual ASCII value of H is 72. But in the array, the value of H is at 7. How do I get my value at position 7 to increment to represent that there is a number for H? That there was a H counted. where does the ASCII value start for capitals? Where does the ASCII value start for capitals, everybody?
65.
And what is the value for H as an ASCII value? It's right here. What is the value for H as an ASCII value? It is 72.
72.
Right. So what is the difference between where the ASCII capitals start and where H is? 65 minus 72 is?
8. No.
Is what?
7, my bad.
Yeah, sorry. And I actually meant to say 72 minus 65 is 7. There's a difference of 7. So this 7 now, you see, it corresponds to H. So this allows me now to be able to say, okay, well, I could exploit that. Because if every position in my array represents a value, and I know what the ASCII value is, right? So I can say, okay, I can now create this array of characters. Sorry. To count my characters. I can now create an array to count my characters. So I could say com_array. And let me just put it one side by itself so that int com_array is equal to, is of size 26. So each array position represents a count of numbers. And I want all of them to have the value of 0. And I do the same for capital, right? So capital_array is 26. So an array to keep a count of each number of the times each character appears, right? Position 0 is common A. Position 1 is common B, etc. And this is the same thing for the capital, right? Same thing for the capital, except that position 0 would be capital A. Position 1 would be capital B. I'm trying to illustrate it to you as best as possible. Are you following where I'm at? Are you guys following where I'm at?
Yes, sir.
Nobody else. Okay, good. Anybody else wants to answer? Give me a little feedback. I am
Yes, I follow.
begging. All
Yes.
right, thank you. Thank you. Right? Remember, guys, I cannot see you all. And if you stay silent, I don't know anything. So I'm going to have to either assume that you're all good and go forward, or you all might be sitting there with a question and I can't help because you're not saying anything. Okay? Right. Yes, Joshua.
So say go on minus the ASCII position from 65 for every number to find it.
Yes. So that's what we do. So if we want to specifically to increment the count position of each character, right? You can see that cap_array at position what? at position int for cent at position n, right? Minus 65 plus plus. Okay, so what is this telling me? It's saying whatever, remember this is a number, eh? This is a number. The ASCII value of position, right? The ASCII value of the current character minus 65, right? What you want to do there is that you want to increment that position in the array, right? So increment. Hi folks, are you all with me? I think I'm back. Are you all hearing me? Could you confirm? All right.
Yes, sir. Yes, okay.
All right. Yes. That's the thing about using mobile data. If somebody calls me, it distresses the whole class. All right. So yeah, so I'm saying here, increment the position in the character count array at the ASCII value of the current character minus 65. So we had, in the case of the word hello with a capital H, we had capital H, right, being the value in center position N. So center, the word was hello. N was here. We got 72 here, right? 72 here. So this is sent at position N. Is if when we do the typecast and get the ASCII value, it's 72. We're saying now in cap array. So if this is cap array, right? Look at what's there. Cap array at position into cent N. So that actually works out to 72 minus 65, right? Would be position 0, 1, 2, 3, 4, 5, 6, 7. So at position 7, you carry that up by 1. So now you have 0, 0, 0, 0, 0, 0, 0, 1. And that's how I get the count for that capital H. And for us to be able to do that for the common, we do the same thing, but just for the common array, right? So we can now say underscore array at position, typecast the int, or cent at position N, minus 60, not 65, but if it was common is 97, right? Plus plus. Because of course for for common characters, the range is from 97 to 122, right? So now we have values inside of that array. So let's see two things. Let's print out the array as it is, and then we'll modify the array to print it out to show only when it have characters. So now we've counted each character, how much times each character shows up in the sentence. And we can say 4, right? 4, and we could use over n. N is equal to what? 0. N is less than 26, semicolon, n plus plus. So for every letter of the alphabet, what do we want to do? We want to print out how much times it appears, right? So we could say printf, percent sign C appears, percent sign C appears percent sign D times. And what is percent sign C? Percent sign C is n plus 65, right? So we can say char, so we're turning it back into the character. And how many times does it appear? Right? How many times does it appear? It will appear cap underscore array at position n times. Okay, so to turn it back into the character, you're using n. N is this 0 here. 0 plus 65 is 65. If I convert 65 to a character, I'm going to get a capital A. You follow? You all follow me? You all follow me here or no?
Yes, sir.
And we could, huh? No.
Yes.
Yes?
Yes, sir, following.
Oh, did somebody say no? I just making sure nobody said no. All right, nobody saying no. Okay, so now if we run it and I enter hello, I get out my capital and commons, and look at this, H appears one time, but then I have a common H appearing one time because I foolishly did not put my com array here. I put cap array here twice. Right? So if I say hello, look at this. E, common E appears one time. In E appeared one time. We have L. L appears 2 times. Right? So we have L appearing 2 times. Okay? But this is a little hard to read. This is a little hard to read. Look at it, typing hello and so much information coming out. Let's eliminate all those 0 times. So we could say if what? If we don't want it to print out when the value inside of cap array is 0, right? Or comma array is 0. So I could say if cap underscore array at position n is unequal to 0. Once the value is not equal to 0, then I want it to print. Right? If the character count is more than 0, then we want to display its information. And we can do the same thing for the common. If com underscore array for position n, right? If com underscore array for position n is unequal to 0, then what happens? Then we print out the value. So let's check it this time now. Enter a sentence, we could enter the same hello. And look now, it starts to make sense in terms of showing what characters appear. Yes? Is this all right? So if we enter a
Yes,
longer
sir.
sentence, right? The rain in Spain, right, falls on the Pope. Look now, only when we have we have a count does the letter show up. So we have a capital A 3 times, a common E 3 times, and it's nice code. Look at that, we got that in less than 50 lines of code. We got that functionality in less than 50 lines of code. So what I'm going to do now is let us take a break, and then I'll come back and do the other things that we asked about. Anybody have any questions about this? I'll send the code for this in the chat one time too, so that we have the code, right? I'll send the code for this in the chat so that we have the code. Anybody have any issues or any questions?
Awesome.
All right, so I'm pausing this first recording and then we'll record the next session, okay?